So this is the beginning part of scientific notation. The 4 goals for today is number 1, how to put a number that is in standard notation into scientific notation. All right, that's goal number 1. However, there are 2 parts to that. In other words, how do I put a number in standard notation when the number is greater than 1? Then how do I put a number that's in standard notation into scientific notation when a number is less than 1? Because there are 2 parts to everything, you're going to get confused and you're going to zig sometimes when you do the zag. All right, because this is what is not confusing is when I'm teaching it to you the rule and we're only dealing with that rule. What gets confusing to you is at the end of this lesson, you will have been given 6 rules. Can you use the right rule at the right time? Because if you use the wrong rule at the wrong time, you're going to be wrong. So that's why you got to know what is the rule and when do I use that rule. And that's where things can be confusing. So that's why we need practice. So that's why yesterday I said, when you get your homework assignment, it's got 30 questions. It's 30 because I need you to get practice. All right, for those of you who play sports, you don't like do the thing one time and then you say, okay, I'm ready for game. You run it over and over and over and over and over again. Okay? You're a cheerleader. You don't just learn to cheer. You don't hear somebody do the cheer and then you just say, okay, we got it ready for game day. You got to practice the cheer. You know, when you're throwing people up in the air and trying to catch them. I don't want that to be the first time. Then again, I don't want anybody to throw me up in the air. Of course, then again, I don't think anybody can throw me up in the air. So those are the 4 things. Now, here's something that you will hear me say. If you walk out of this room and you understand how to do those 4 things, then I earned my paycheck for today. I did my job. On Monday, if you come in here and you remember how to do those things, that means you did your job after school. Got it? So if you understood it when you walk out, but you don't remember it when you walk in on Monday, that ain't my fault. Okay? That's yours. That's where your job comes into play. My job is to make sure you understand it. Your job is to make sure you remember it. And whatever way you do that works for me. Okay? But again, that's my goal for here today, these 4 things. Are we good? I'm not going to be as slow as I was with physical science because your chemistry, you should be higher in math, so I should be able to go through things a little bit quicker. All right, but these are the 4 things. Do we have it written down? Because I want to make sure. Because again, when you look at day 1 and you go in and you say, hey, what were we doing on day 1? Well, what's the goal? Those 4 things. If you can say, I can do that, I can do that, I can do that, I can do that, then you understood the lesson. Okay? That's how it is. It's point right there. We good? All right, so here we go. First question. Obviously, if your topic is scientific notation, my first question is going to be, what is scientific notation? All right? So, scientific notation is a way to shorten a very long number. Okay, a very long number. Now, I'm going to give you an example of what I mean by that by asking you to do something once you've written down that line. Speaking of, if it's on the board, I strongly recommend you write it. That's why I put it on the board. If I put something on the board and I don't want you to write it, I will clearly tell you, you don't need to write this. Okay, but I have not said that about here. But again, do you got to write any notes? No, because you ain't got to do nothing but stay and die, right? So, here's what I want you to do. Once you've written down that line, I want you to go to the next line on your paper, and I want you to write a 6. Okay? You write the 6 however you write the 6. Some of you write big, some of you write small, some of you write average. But write the number 6 underneath it. Everybody done that? Mm-hmm. Now what I want you to do, and there's a point to this, so don't just say, I ain't doing that. There's a point to things. Okay? I want you then to put a 0 after the 6, and then I want you to keep adding zeros until you run out of room at the end of that row. But just that row. You don't got to go down to the next row. Okay? Just on that one line. Just keep adding zeros until you run out of paper. But just one line. I'll give you a minute. Not even a minute. I'll give you some time. Zeros. They're just circles. And then once you've done that, count how many zeros you had after you were 6. And then you may want to write that somewhere in the margin or something. That way when I ask you, you ain't got to count it again. All right, so everybody's good? Now, if I call on you, don't share with me anything if you didn't write zeros all the way across your paper. Like if you just went here and said, I ain't doing no more of this. I'm going to go sell some drugs. Then don't tell me you don't share anything with me. Got it? All right. Got to get familiar with some names. Mykera Barnes. Okay. How many zeros did you have after your 6? 43. All right. Cameron Jones. How many zeros? 48. 28. Sorry. 28. Kelly Grimes. 19. You raise your hand, you're stretching. Oh, you're stretching, okay. All right, but now you got my attention. Essence. 28. All right, what was the biggest number he had so far? 48 or 49? 43? No, somebody had 40.
No, I had said, you know I said 48, but I had said.
Oh, maybe it was that. What'd you say?
Huh?
What'd you say?
I ain't saying nothing.
I know, so what'd you say now?
55.
55, goodness gracious. All right, she got small. Who can beat 55? Nobody can get 55? All right, I mean, it ain't a competition. I was just wondering, right? Now do me a favor, get your calculator. Okay? Because all I'm trying to do right now is this. When we doing, look, I can tell you this. Tonight, that reality ain't you ain't doing nothing tonight. All right? Then you ain't doing nothing tomorrow. Okay? The reality is, I'm going to guess about 6 of you ain't going to do nothing on Sunday either. But on Sunday afternoon, when you're doing the homework, you're going to get asking the question, why are we doing this? So I'm showing you the reason why we're doing this. Okay? So what you do is get your calculator, turn it on. And then I want you to press the number 6. And you see the 6 on the screen, correct? And now I want you to do is add zeros until, add zeros until the 6 is so far to the left of the screen, but it's still in the screen. Because if you hit too many zeros, the 6 will go off the screen. So hit zeros until the 6 is as far left on the screen, but it's still there. You can still see the 6. Got it? And then, once you have gotten to that point where the 6 is on the left side of the screen, count how many zeros you have after the 6. Here, we should all have the same answer. So for that, I'm going to throw it over to Terry. 9? Jared, you agree? So we got 9 zeros, right? All right. So let's use Cameron's number. You including the 6? Mm-hmm. Yeah, we meant just how many zeros.
Not including 6.
Try again. Like, don't tap it. Just count again. You know what I'm saying? Just count your zeros again.
You got the tissue.
Over there. Cameron, you had 28 zeros on your paper, right? Yes, sir. All right. So here's my point. Cameron, the number on your paper, could you type it onto that calculator?
Like the 6 number or 28?
Could you write 6 with 28 zeros behind it? No. Because all you can see on that screen is 9 zeros, right? So the number's too big. That makes things complicated, even for a calculator, right? So you would say, well, I ain't doing all that math. I'll just do it on a calculator. Okay, well, type in that number in the calculator. You can't. So what do you do when the number is too big to even go in the calculator? That's the point of scientific notation. It's a way to say, I'm going to take a long number and I'm going to shorten it so that it's easier for me to use either on paper or it's easier for me to use on a calculator. Are we good? Mm-hmm. That's the whole point. Okay? So go ahead and write that down. You'll get to your calculators in a little while. But right now, I just want you to understand, the numbers we deal with sometimes are too big of a number that even a calculator would be an issue. So I need to adjust this so that the calculator cannot be an issue, or so that my brain can't be an issue. Now, so all we got right there are the 2 reasons why we are going through all this effort. Okay? It's the why. What is your why? Well, why are we doing this? So we learn how to deal with numbers that are huge and deal with them in a smaller, easier to manage format. That's the reason why. Now, a number that's in scientific notation. So let me give you it real quick. You don't need to write this one down. What I'm writing on the left side, you don't need to write. Okay? But for example, that's the number that's in scientific notation. Okay? So that number up there, matter of fact, let me do it a different way for you. I'll do it a different way for you. All right? Does anybody not care about sharing what year they were born?
2002.
2002, says the young lady in the back. All right, so 2002. That's the number you're used to looking at. You don't need to write this down. Well, no, write this down. Now you can write this down. Okay? Yep, whatever the last thing you wrote.
You want us to write that question?
Yep. Yep, I don't care. It don't, whether you put it before, whether you put it after, it ain't going to mess anything up. She's born in 2002. Okay? That's the way you normally would write 2002. Correct? Like if you had to write this down, you'd write 2002. In the calculator, you'd write 2002. Makes sense. Mm-hmm. But remember, when you got Cameron's number with 28 zeros after it, you ain't typing that in the calculator. So this here, this is what we call standard. This is called standard notation. This is what you are normally used to. Okay? That's the way you've always been doing numbers your entire life. However, that same number in scientific notation looks like that. Same number. Same value. Okay? It's just in a different format. So like if somebody said, hey, I'll pay you that much money right there. All right? Well then, hey, I'll pay you that much money right there. Oh yeah, give me that one, man. That's a whole lot more. No, it's the same thing. It's just a different format, different presentation. Okay? So when you look at it, standard, scientific, there are some differences between the two. Hence the question, how is it different than a normal number? Well, what's one of the things you notice that's different? Who what? Okay, what about it? Like what's different between this written and this written? Decimal and exponent. Okay, so we got a decimal, we got an exponent. The exponent is the most obvious thing, right? Now, here's what I want us to do. Okay? There are two things that make the scientific number different than the standard number. All right? The first thing, and I'm going to highlight them in red so that way we don't get confused later because we need to get used to these words. What I've highlighted in red is what I call the integer. So when it says number one integer, that's what I just circled in red. That's the integer. More commonly, it's the part that goes in the front. Because you got the stuff in the front, and then you got the times 10 thing. Well, the stuff in the front, that's the integer. The thing over here, the times 10 thing, that's what I refer to as the exponent. Okay? Officially, it's called the power of 10. All right? Officially, it's called the power of 10. All right? Now, changing topics for a second. Remember, you chose today where to sit because that's where you sit from now on. Which means if you chose to sit at a flat white top table at a flat black top lab counter, you chose to say, I'm willing to put my phone on top where the teacher can see it every day. So make sure we are under that commitment. Integer exponent. All right, everybody see where they are? Because again, sometimes I may say, hey, what's right with this problem? You might say the integer's right. All right, you may say, hey, was the exponent right? And you have to look at the exponent. So I want you to know when I'm saying the words, what exactly I'm talking about. That way it doesn't slow things down. Now, notice my integer right here. When it says integer and it says must be 1 through 9, this is what I mean. Take a look at the integer on the example that we have on the board, right? The integer, see the decimal? That's a yes, no question. Yes? How many numbers are in front of it? 1. A correctly written integer can only have 1 decimal in front. Sorry, I said it wrong. Can only have 1 number in front of the decimal. All right, let me say that again. Your integers, when written correctly, better have only 1 number in front of the decimal. And that number better be 1, 2, 3, 4, 5, 6, 7, 8, 9. It can't be 0, can't be 10, because 10 is 2 digits. 0 is 1 digit, but it ain't 1 through 9. You follow what I'm saying? So make sure if you have a integer that has got 2 numbers in front of the decimal, then that ain't good and you got to fix it. And I'm going to show you how to do that. Okay? This is the exponent. The exponent, right, can be either positive or negative. And that's why it's going to get you confused. Because sometimes you're going to do something to get you to the positive. The next time you're going to do the exact opposite to still get you to the positive. And that's going to confuse you. And I'm going to say, you zig when you should have zagged. So it's important that you kind of know these particular parts. Are we good right here? Great. Then, from here, I don't need a projector. I just need my brain. All right? So, with this right here, I need somebody to tell me, what was number 1 in our goals for today? What was number 1? Standard to scientific. Great. So let's go ahead and write that down. Because now I need to show you. My job today, number 1, is to show you how to go from standard to scientific. I'm starting off with the more complicated of the two tasks. So what was number 2?
Put scientific notation to standard.
Scientific to standard, right? Scientific to standard is kind of easy. And it's a whole lot easier once you learn number 1. So I'm starting off with the more complicated one because that's the one that always has my kids getting issues. All right? If I started with number 2 first, you'd say, oh yeah, this is easy, man. I got this. And then you really wouldn't pay too much attention. And then what happens is you get to number 2 and it screws up your mind. Okay? And it takes like too long for you to recover. So standard to scientific. So there are 2 parts. Okay? There is, so part 1, like right now, number 1, goal number 1, standard to scientific, right? But there are 2 rules we got to learn. So that's where I'm putting next to the A. All right? In the A, the rule is this. If the number is greater than 1. Okay? So that's your situation. So when you get a problem, you have to say, oh, I'm trying to put this into scientific. Okay, well, look at my number. If my number is greater than 1, then I need to do this. What if my number is not greater than 1? Then you're going to do something else. So you got to identify the situation. Okay? Like Jared, simple. You're at the club. You're talking to somebody. She looked good. You see an Adam's apple. What do you do? All right. No, I don't. I don't know you. Oh, okay. So in other words, so once you identify the situation, you might say, I'm going a different direction. All right? Because it's a preference thing, right? Other people have that preference. It's okay. It's 2019. There we go. So if the number is greater than 1, here's what we got to remember. If I have to move the decimal to the left, then the exponent is positive. Here's a good note. Victor Tyson wants me to share this with you. If you write your notes so messy that you can't read them, then it won't do you any good later on when you're trying to do your homework. All right? Because I had Victor do a problem in class today during first period. And I said, well, look at your notes. What did you write? And he read, and he's like, I don't know what that says. I go, well, you wrote it. Okay? He didn't know what his plus symbol looked like. And I looked at his paper. It didn't look like a plus symbol. So you got to make sure you write your notes in a way that you can read it.
The exponent is positive.
The exponent is positive. Okay? I would say this now. Ready? If you got a highlighter, highlight that sentence. Because if you don't know that sentence, then any quiz or test, I'm going to confuse you. Like I'm going to trick you. You got to know that rule. Okay? So this is a rule. Maybe I'll just write it right here. Rule. What does this rule mean? So let's take a look here at the situation. Let's take a look at the number. Let's start simple. 175. Okay? That's the number. Elijah? That number. Standard or is that scientific?
Standard.
That's standard. Unless you're Elijah?
Sorry.
It's okay. I didn't know. I just thought you might have been a black lady. All right. So 175, right? Here's the most important question of the day, and it's kind of a simple one. So simple that some of you might get it wrong just because you don't even think it. You're probably making it more complicated. So, Terry, question. Where's the decimal right now?
The one? Like which one?
The decimal?
Oh, there is no decimal.
Okay. Jacob, there is a decimal, but where is it?
Behind the 5.
Behind the 5. Okay. So that's the one thing. Because remember, what does the rule say if I'm moving my decimal? Well, shoot. If you're moving your decimal, well, what if you started off with your decimal in the wrong spot? Then everything you move is about to be wrong anyway. So the first thing you got to do is know, where is my decimal? Sometimes it'll be obvious. Don't write this down. Sometimes it'll be obvious. Where's my decimal between the 1 and the 5? Sometimes it won't be. When you have a whole number, the decimal is always at the right end of the number. Okay? So when you don't see a decimal, there's a decimal. It's called an implied decimal. Are we good with that? Speaking of, if you don't get something, and I say, are we good? If you ain't good, you better stop me. Because when I say, are you good, and you don't say anything, that means I'm moving on. With the assumption that you got it. And if you're confused, then it's your fault for not letting me know. So my decimal is right here. Okay? That's where my decimal is right now. Are we good with that? Now, if my decimal is right there and that were the integer, would I be good? No? All right. So then my question is, where do I want to put my decimal? Okay. Behind the 1 and in front of the 7. So I'm going to put an X right there. Just to kind of get a point across to you right now. So see where the dot is? See, X is the spot where I want to go, right? To go from the dot to the X, which way am I going? Left. So when the rule says move the decimal to the left, right? That's how I know whether I'm going to the left or to the right. It's where's my decimal now, but where do I want my decimal to be? There's your sign. No. Okay. Okay. Right, get it. Sorry. So, now, I know my exponent is going to be positive, right? How many places am I moving my decimal? 2. Okay, I'm going once, twice. So now I know my number for my exponent. My exponent number is going to be what? 2. So when I do that, I'm left with a 1.75 times 2, right? Times 10 to the second power, because I moved it 2 spaces. And because I moved it to the left, that 2 is a positive 2. Okay? What?
Will it always be a 10?
Will it always be a 10?
Yeah.
The times 10?
Yeah.
It will always be a times 10.
Okay.
Yes. All right? And that's how you put a number greater than 1 from standard into scientific. All you got to do is say, where's my decimal to start? Where's my decimal going to be? And what direction am I moving? And how many spaces is it moving? Follow that? Let's see if we can. Carlos?
I know if it's a 10. Is it always going to be a 10?
That right there?
Yes.
Yes, it's always going to be a 10.
No.
All right? That's okay. I figured it would have been reversed. I figured you would have said it, then she would have followed it, because usually she don't listen. All right?
Basically, the very first number of the whole thing, the decimal goes behind.
The very first number that's between 1 and 9.
No, like the 1 and 7, the very first number.
Right, you're talking about that number.
Yeah.
Right, I'm saying as long as that number is between 1 and 9. Like if that number would have been 0, then I ain't putting it there.
I know.
You know what I'm saying? That's all. I just want to make sure. Like what you were saying, I heard it. I'm just adding something to make sure that I'm clear, because I don't want somebody to say, well, you said put it in front of the number. Yeah, but that number's between 1 and 9. Like if that number's 0, I don't want that number. Okay? We good? Let's see. Let's do another Juan. Shoot. Not what I want. Sorry. There we go. All right. There's your number. Put that in scientific notation. Just do it on right now. Just do it on yourself. Just do it silently or on paper. I'm just giving you time to see if you can get it. Yes. All right. I start off with the basic question first. So basic, I'm going to ask Damien the question. Damien, where's my decimal right now? There's a lot of them. The last one. All right. So my decimal is right there. Okay. Essence. Where do I want my decimal to go?
I say in front of the
In front of the 3. So put it right there. You guess? All right. Give me a second here, Essence. So if I put it there, what number then is in front of the decimal?
0.
Okay. Is that a good number to have as an integer? Then I probably don't want to put my decimal there.
I mean, behind it.
Behind the 3. Okay. If I put it there, how many numbers in front of the decimal?
4.
Hold on.
Oh, my bad.
You're good. First of all, that's not in front. But
That's why
I got you.
The number 3 would be in front of it.
The number 3. So one number, and it's a number 3. Does that fit the requirement for the integer? Then that would probably be where I want to be. All right. So dang, forgot her name. Man. Jamitra. So to go from dot to x,
Do it 4 times.
4 times. So when I do, I get 3.0070 times 10 to the 4. Right? Now, that number, positive or negative? The 4. Like the 4 here, is that going to be positive or negative? Positive, because I went to what direction? Left. That's why it's positive. Are we good?
You
All right.
Put that extra 0 behind 7.
It don't matter right now, but on Monday it will.
So you don't care if we put that on our homework?
Nope. But on Monday I will. Okay? Because on Monday, significant figures. That means on significant figure day, that means some of these zeros count, some of them don't. Okay? All right. Are we good? That's part A. We're still at part 1, but that was the if the decimal moves to the left. So the second rule is, what if the decimal moves to the right? Well, that would be because your number is less than 1. Okay? So if your number is less than 1, then you're going to move the decimal to the right. And if you move it to the right, then the exponent is what? There you go. So it's not too complicated, but it's complicated when you get it mixed up. That's the reason sometimes you're going to zig when you should have zagged. So in this scenario right here, we're going to get a number that's less than 1. So let's get 0.000751. Okay, there's your number that's less than 1. Jacob, where's the decimal right now?
The very left.
The very left, because it's right there. Okay, like that one you can't screw up. Well, let me rephrase that. People have, but you shouldn't. Now, my question is this. Dolberry. Because I don't, oh, thank you. Sorry. At some point I'll remember everybody's names, but not today. Dolberry, where do I want my decimal to be?
Behind the 7.
Behind the 7. All right, this is behind the 7, right?
No.
I mean, it's behind the 7.
Behind the 7 and the 5.
Between the 5 and 7.
Between the 5 and 7. Oh, look at the major over there. I got confident. Between the 5 and 7. Not often that I hear southern accents from black folks. You know what I'm saying? So between the 7 and the 5, right? So now, Malaysia, which way am I going? To go from the dot to the x.
Are we going right?
I'm going to the right. That makes my exponent what now? Negative. So therefore I know this. I'm going to have 7.51 times 10, and it's going to be to a negative number. Negative 4. All right. How many spaces did I move it? 1, 2, 3, 4, right? So therefore, 4. And that is my standard number of 0.000751 in scientific notation. Okay? We good?
We would move it to the right when there are like zeros in front of the number.
Less than 1. All right? We good? All right, here we go. Let's try this one here. Go ahead and put that one in scientific notation. By the way, I'm just going around asking different people, so if I ask a question, don't raise your hand because I'm trying to get everybody to get a question at some point. However, just because I asked you a question don't mean I want to go back to you again. All right. Tyler, where's my decimal to start?
You said what?
Where's the decimal to start?
In front of the 0.
All right. Where do I want my decimal to be?
Behind the 1.
All right. Conseco, only tell me what the integer is going to be.
Measure 1.05.
Barrow, what's the times 10 thing going to be?
Negative.
Giovanni, is she right?
Yeah.
All right, she's right. And if you don't agree with her, then raise your hand and tell me so I can fix why you're wrong. Everybody's good? Any questions on how to do? Go ahead.
Why we put it between the 1 and 0?
Because
Like why we wanted it?
that's my first number. That's going to be between 1 and 9.
Okay.
You know what I'm saying? Because let me really fix what your issue is. Where do you think it was going to go?
With the 5.
Here?
No, behind.
Here?
Mm-hmm.
Because then what happens is this. If I put that there, I end up with that number. How many numbers in front of the decimal?
2.
And I can have 1. See what I'm saying? So that's why. Because I knew you were thinking something, so that's why I want to make sure I fixed what you were really thinking and not just answer your question. Any other questions about that one? So we're good? We'll find out. By the way, I'll give you a heads up. After I go through my 1, 2, 3, 4s, then I put problems on the board and call somebody up to do them. So that's what I'm saying. You might want to get it fixed now. Like if you say, I don't know what you're talking about right now, then let's do it now before I call you up to the board and everybody just stares at you and you just stare at them and it's awkward. All right. Number 2 says what? Perfect. So this is scientific to standard. Now you're going to notice this is a whole lot easier to do now that we started off with the other one first. Okay. However, there are still 2 sets of rules because it's based on the exponent. All right. So if the exponent is positive, then you will move the decimal to the right. Okay? Now, if you were looking at the rule before, you said, well, last time the exponent was positive, we had it because we moved it from the left. Correct. Different situation, though. That's why I'm saying this can get confusing. So the first thing you got to do is you got to lock down these rules in your brain. Because if they ain't locked in your brain, then you're going to second guess yourself. And as soon as you second guess yourself, I win and you lose and get the question wrong. So the exponent is positive. So let's just start something simple. Let's just go with 1.5 times 10 to the 4. Right? 1.5 times 10 to the 4. This is how simple this one can be. All right? I take my integer, right? Here's my integer, 1.5. What's my exponent? 4. Positive or negative? Positive. So I know this. Because it's a 4, I'm going to move my decimal. How many spaces? 4. Because it's positive, I'm going to move it what direction? Right. To the right. So I'm going to go here and I'm going to say 1, 2, 3, 4. Fill in these gaps with zeros. When I do that, what's my number become?
15,000.
15,000. And that's your answer. That's all it is. Okay? That's all it is. Does anybody have any question or confusion on that? No. I mean, because that one's kind of straightforward. But the key here is this. What determines what you do is the exponent. Okay? When that exponent is positive, that means you got to move your decimal to the right. All right? So I'm just throwing it out there. All right. Let's go to B. Can I go to B? Mm-hmm. So nobody's stopping me. Not even Damien, who's got that confused look. The reason why I know he's okay is he's always got that confused look. You should see him wearing a hoodie. All right. If the exponent is negative, then you're going to move the decimal to the left. Okay? So if the exponent is negative, so that's why knowing what the exponent is important, because that's the thing that's kind of telling you everything that you're doing. So if you're looking at the wrong thing, you're going to have issues. So let's say we get the same number. Okay? Go ahead and do it if you think you know what you're doing. All right, I got 1.5 times 10 to the negative 4. Okay, 1.5 times 10 to the negative 4. Pretty good. And then go ahead and convert it over to standard notation. And we'll see if you're right. If you don't got it, say I don't got it. If you need 10 more seconds, say 10 more seconds. So I can ask anybody in this room and they're going to give me an answer. Tequila, give me your answer.
0.0015.
All right. She got 0.0015. All right. Hold on. Wait a minute. Oh, sorry. Another zero?
Yeah.
Okay. We're going to go back. All right. Malaysia, you agree or disagree?
Agree.
You agree. Okay. You can see? Okay. You squinting your eyes there. Victor Tyson was squinting his eyes too, and he couldn't see nothing. Is that a 3? Dude, that's a comma. All right. Carlos, agree or disagree? Thank you. So, by the way, I do deflection. Like, I will literally look at her and then say, Tyler, what did you get? All right. You know the kid named Jonathan Lockamy? No? Okay.
Who?
All right. Huh?
Jonathan Lockamy?
Yeah.
Was he like older?
Yeah.
That's the one who passed away from cancer.
I believe so.
Yeah.
But I had him as a student. Had a great picture.
Yeah.
Because one time he fell asleep. And he felt just like that, except his mouth was open. So he was like this. He's like. So I shot a paper ball and I made it in his mouth. You know what I'm saying? But yeah, he was one of those. I don't know. I kind of like having him in class. 1.5 times 10 to the negative 4. 1, 2, 3, 4. That is correct. Okay, good job. All right, that is correct answer. Anybody got any questions on that one? So we ready to roll? Let me throw you a couple of weirdos. Just a couple of weirdos. Like this here, kind of it goes either A or B. It don't kind of matter. All right? All right. So. All right, tell me what answer you get. Hold on, I'm going to do both. I'll do both. Okay, do those two. Maybe about 30, 35 seconds.
Is that a 0 for exponent?
I believe it is. It's the same number, the number of games you started. Jared, have I asked you a question other than what would you do if you saw an Adam's apple?
No.
Okay, I still got you on my radar. All right. By the way, you can be wrong. You know what I'm saying? Like, the whole point is, based on what I've taught you, do you have a thought? And then if your thought is correct and good, if your thought is wrong, we got something to fix. If you need 10 more seconds, say 10 more seconds. All right, don't let me call you and then you say I ain't done. That's why I say take 10 more seconds. All right. Man, I was going to go to somebody before I went to Jared. He went to Jared's. All right, let's see. Oh, you know what? Hey, Country Mart, what'd you get for that one?
3,000.
3,000? All right, he got 3,000. Man. Mykira Barnes, that's you. Is that right or wrong? Like, agree with his answer or you disagree?
I would other way.
You went the other way. So you got .003. Okay. Is that a positive? Okay. Well, when it's a negative, you go to the left. Okay. So when it's positive, you go to the right. All right. Okay, man. Hey, what's your name?
Kill. Okay.
Kelly. Gotcha. Grimes. All right, Kelly. You agree or disagree?
Agree.
You agree? He's right. That's 3,000. If you don't agree, then you better tell me because I got to fix it. Like I fixed it with her, so that's good. All right. Everybody straight?
Yeah.
Jared, what'd you get? 1.5. Okay. Terry, agree or disagree?
Agree.
You agree. Why do you agree?
Because it's a zero.
So? Oh, it doesn't go anywhere. Good.
Equal one though, right?
Kiss my what?
Don't equal one.
No. Well, no. Well, look at it like the way I teach. When I said 3, how many places? Demetra.
It do equal one.
Breathe. Demetra. You listen to everybody but me. Somebody be like whispering something, you look. I'm over here trying to tell you. Right here. That meant we move it how many places? 3. So that's the number that tells me how many places to move. How many places am I moving it?
Zero.
Nowhere. Right? So it ain't about whether it equals 1. It's about, that's a 0. I don't move my decimal. Do you follow?
But still gonna move it one time.
Actually, you ain't. That's what I'm saying. If you moved it, hold on, what was, Demetra, I ain't trying to make fun of you. So my question is, what did you have as your answer? 15?
I ain't putting that. I thought it was 15.
Okay, good. So you thought it was 15. But, so in other words, here's my integer, right? Well, that exponent says I'm going to move my spot how many places? 0. So that's my answer.
If I was taught 10 to the zero, probably equal one.
Well, even if it equals 1, 1.5 times 1, hold on, calculator. Do you get it?
Yeah.
Do you really? Do me a favor. Go to your calculator. Do 1.5 times 2. Okay, good. Now do 1.5 times 1. All right? You know what I'm saying? So even if you would have done 1.5 times 1, you still don't get 15. Right? So kind of either way. Are we good? All right. Let's go to number 3. Number 3, multiplying and divide scientific notation. Let's start off with the first thing. Let's start off with multiply. There are 2 things you got to do when you multiply. Okay, scientific notation. Number 1 is you got to multiply. Duh. Multiply the integers, though, specifically. You're going to multiply the integers. That's why I said you better know what the integer is. Because if you don't know what the integer is, when you start multiplying integers, you're going to be like, oh, multiply, and you're going to multiply everything. No. Just multiply the integers. Okay? The second thing you're going to do is you're going to add the exponents. Okay? You're going to add the exponents. So, let's put a problem up here. All right? We're going to go 6.8 times 10 to the 4th times 1.2 times 10 to the 6th. Okay? So here's the problem we're trying to do. Now, I can tell you this. If I were to give you that problem at the very beginning of class, some of y'all would just be like, I don't know, nothing, just quit. Okay? But I'm going to show you, now that you know what to do, it's going to be actually quite simple. Especially since, 1, you know what you're looking at, and 2, you know what to do. So what's the first thing you got to do?
Wait, with standard form?
You're gonna ready. This is where you repeat what I wrote. You just multiply the integers. Okay, you're good. I mean, because here's the thing. I heard three different things. That got me confused. All right. So you're gonna do 6.8 times 1.2. That's an integer. That's an integer. Right. So you're gonna do 6.8 times 1.2. Okay. So when you do that, Bobby Andrews, tell me what you get.
8.16.
3.16. 8.16. She gets 8.16. Is that a good integer?
Yes.
That's good, because if it ain't, you got to fix it. Which reminds me, after we do this problem, I need to show you how to fix it. All right? Because that's where things can get really bad, if they're going to get really bad. Now, what the next thing I got to do is I got to do what? Add the exponents. What's that exponent?
4.
What's that exponent?
6.
What do you do when you add them two?
10.
Then therefore, we're going to go 8.16 times 10 to the 10. All right? Jamitra, if I was putting this number in normal, how many times would I move my decimal?
10.
Good. What way?
Right.
Good job. All right? Just making sure. Hold on. Jacob, go ahead.
How did you get 10 again? What was the base?
How did I get 10? Because I added the exponents. So, cuatro, seis, diez. All right?
And you multiply the integers.
Correct.
With the under 9.
No, I multiply the integers if that's what they give me.
Okay.
Like whatever it is they give me, I multiply them. Because in the end, if my integer is in bad form, bad shape, then I got to fix it anyway. All right, like let me give you one that's going to be in bad shape. 6.8 times 10 to the 4 times 2.2 times 10 to the negative 6. Okay, I'm doing that one just for giggles. All right. So, Mr. Powell, do me a favor. Multiply the integers for me, and I'll come back to you for an answer. All right, and I'm gonna get Cameron to go ahead and multiply. To add the exponents, and then I'll come back to you in a minute.
-2.
Double check. Just make sure. All right. So we're doing this because remember, y'all are doing this thing yourself, right? So don't just listen to everybody else. Do it yourself. Get used to the process. Because you're going to get practice. You're going to get a lot of practice. All right. So, Mr. Powell, have you got the integer yet?
14.92.
14.96. Is that what you said? All right. He's got 14.96.
You can fix that.
Okay. So right now I know that's going to have to get fixed. But I ain't going to fix it yet. Okay. I need the other part. Which is times 10, right? So here we go. What's my exponent going to be, Cameron?
-2.
-2. Because when I do 4 plus -6, that gives me -2. All right, you ready? Who's got that number written down? Because I'm going to erase my board just so you can see this whole thing. Because I'm like me on the dance floor. I need some room. Okay? So everybody got that number written down? Mm-hmm. Now I got to show you how to fix it. Some of you are going to have a moment. But it's okay. You can have your moment all day. Is that a good scientific notation number? No. So, got your rules in front of you? Good. We're about to find out if you can read them. So this is bad, and I need to fix it. Okay? So my question now is this. Singleton. What up? Which way do I got to move my decimal to fix it? To the left. Okay. How many spaces? 2 spaces. All right. So it's going to end up here. 1. All right. Everybody agree I need to move it 1 space to the left?
Yeah.
Great. Because when I do, that's going to give me 1.496, right? Now, here's what I need you to see. If I move it 1 space to the left, what does the rule say? Move it. You sure? Positive. Because what were we looking at right now? We're looking at the 1A. Everybody see that? Because right now I'm still trying to put this number into correct scientific notation. So I'm looking at 1A that says if I move my decimal one spot to the left, that makes it positive, right? Positive. How many spaces did I move it again? 1. Positive. Positive. 1. So now Cameron, need a favor. -2 plus 1. What does that equal? -1. That's your final answer.
So when you fix like a problem like 14.96 and you move over one, that exponent doesn't matter in that way.
The exponent that is there then is going to get used to make a new one.
Yeah, but it doesn't matter how many you move it to.
No, because it's already set there. But now that I'm making another adjustment, then I'm going to have to make another adjustment to my exponent. Okay? Carlos.
So the answer is arguably scientific multiplication.
Oh, yeah. For this class, because this is the part of the lesson, anytime that I'm giving you multiply things in scientific notation or divide things in scientific notation or add or subtract things in scientific notation, I want the answer in scientific notation. All right? Because that's kind of the point of the lesson. All right, Terry?
Will you ever subtract? Or
Yeah.
is it always going to be?
No, we only done multiply right now. We still got to do divide. All right? But I was just wanting to throw that whole, what happens if my number ain't right? You know what I mean? Like, it's in scientific, but it ain't in correct scientific. I still got to make an adjustment. That's what I'm letting you know. Okay? That's what I'm letting you know. I can already tell. Right now, the eyes were great before I did that right there. Because it was like, got it. And now the eyes are like this. Okay? So, don't worry. We're going to do some more. But let's go to divide. Let's go to divide. So this is B. 3B. All right? Divide. I'll give you a clue. It's going to be very simple. In multiplying, what was the first thing I did? In multiplying, what was the first thing I did? Multiply the integers, right? So guess what? In divide, what do you think is the first thing I'm going to do? Divide the integers. In multiplying, what was the second thing I did?
Add the exponent.
Add the exponents. What do you think is going to be for division?
Subtract the exponent.
Subtract the exponents. So you can see now part of your battle is you got to identify first what the situation is. Once you see the situation, then you know what rule to use. But if you don't spot the situation first, like if you just start saying, I'm going to use rule 2A here. Why? I don't know. Then I don't know what you're doing either. Okay? So let's take the same number. I think it was what, 6.8?
Yeah.
Times 10 to the 4, correct? All right, we're going to do divided by 1.2 times 10 to the, was it negative 6?
Yeah, no, six.
No, it's fine.
It was 6 that I gave you the first time?
Yeah.
Okay, that's good. I'm working with that. All right, so go ahead and do, because like I said, it's the same thing. It's the same process except just division this time.
You were on the top.
What?
No.
Sometimes you have to forgive her. She knows not what she does. All right. Integer. Goldberry, what'd you get? 4. 5.67. All right. She got 5.67. Okay, I'm good with that. Somebody might have said I got 5.667. It don't matter. On Monday it'll matter, but today it don't matter. Like if you put 5.7, it don't matter. On Monday it matters, but not today. Essence, what do you get for your exponent? -2. Good job. And there's your answer. And again, 5.67. Do I got to fix it? No. That's when you always go, oh, thank God. Because what if it was like, 56.7? And you're like, oh, crap. All right, I got to move it to the left. So I got to add 1 to the exponent. The exponent is -2. -2 plus 1, that's -1. You know what I'm saying? There's a whole lot more crap that you got to do afterwards if that ain't fixed. So if it's already fixed and nice, then you're like, thank you goodness. But when it ain't, then you kind of get a little bit crazy. But don't worry, you're going to have to do what we're doing now for everything in the adding and subtracting. Are we good right here? Anything I need to fix for anybody? Okay, we're getting close to that time. That time when I start calling people up. All right. This is number 4. Adding and subtracting. Okay. When adding and subtracting, you add or subtract the integers. Okay? However, so I'm going to let you catch up before I say this, because I don't want you to get confused between what we've done in multiplying and dividing. Okay? So you're going to add or subtract your integers. But before you do that, all exponents have to be the same. Okay? They have to be the same before you ever add or subtract. Okay? They got to be the same. Which means if they ain't, you're going to have to make it the same. So let me give you an easy one. Easy would be this. 5.3 times 10 to the 5th plus 1.2 times 10 to the 5th. Okay? So, before I look at my integers, I look at my exponents. Okay? What is the exponent for the first one? 5. What's the exponent for the second one? 5. Is that good?
Yes.
So then all I got to do now is take a look at my integers and add them up. And when I do, what do they add up to be? 6.5, which means it would be 6.5 times 10 to the 5th. That would be my answer. So nothing changes on the exponent end. Okay? It just stays times 10 to the 5th power. That's all. That's all. Where your life begins. It's the same thing for subtraction. So if I would have changed that plus right there and changed it to a minus, you would have done 5.3 minus 1.2. And you would have gotten what? 3.1 or 4.1. Okay? So it's the same thing. The key here is you better make sure them exponents are the same. Okay, but it's not what happened if they ain't. All right, let's do that. 5.3 times 10 to the 5 plus 1.2 times 10 to the 3rd. Okay? So, the question now becomes is this. What do I do? All right, when I need to make the numbers the same? The answer to your question is this. First thing you need to do is figure out which one are you going to change. Are you going to change the 5 to make it a 3? Or are you going to change the 3 to make it a 5? It don't matter which one you do. You should still get the same answer. Okay? So I'm just throwing that out there. So, which one you want to do? Change the 5 or change the 3? No, I'm sorry. I know. My fault. You all agree, though? You said 3? What'd you say? You said 3? All right, we're in agreement. We're going to change the 3. Right? Who remembers which way I got to move my decimal to make the number bigger?
Right.
Okay.
Wait.
I'll give you a clue. You ready? This is why I say the rules are important for you to memorize up here. We're looking at rule number 1A. Okay? Rule 1A says, if move decimal to left, make exponent positive. Right? Because right now I'm trying to add to that exponent, correct? So I need to move that decimal to the left. How many spots do I need to move it to the left? 2 spots. So here we go. 1.2, right? 1, 2. What do I do with the gap? 0. There's my new integer. 0.012. Did you catch that? Because for some of you, I blocked your view. Why do I have to do 2? Because I'm trying to make that 3 become a 5.
Oh.
Okay? And so when I move that spot 2 spots to the left, right? 2 to the left, positive 2, that makes it now become a 5, right? So now I have, like in a sense, now I have my new scientific number right here. 0.012 times 10 to the 5th. Do they match now?
Mm-hmm.
Now I got to do is add them up. 5.3 plus 0.012, and you get 5.312 times 10 to the 5th. Is my integer good in my answer?
Yes.
Is my exponent good in my answer?
Yes.
Then I'm done. It's the same thing you would have done for subtracting. All right? I love how the confidence levels in the faces just went, now y'all some of there. Okay? Those are the 4 things. I can tell you right now, you're probably good with number 1, you're probably good with number 2. I'm pretty sure you're good with number 3, as long as it don't come up with like a 14.68 integer. All right? And then with adding, subtracting, I know you're going to struggle. But let's get some practice. Hence, this is the ending of the recording of this video.